Good morning students. Now we will cover up analog electronic circuit. First of all, we will differentiate two signals. What do you mean by analog signal and what do you mean by the digital signals? Analog signal, first of all you know the basic things. What do you mean by analog signal and digital signal? Analog signal what is the basic difference between analog and digital signal? What do you mean by signal? Signal, it is a physical quantity that varies with time, space and with any other independent variable or variables. Signal which itself contains some information for observation. So, signal carry information for observation. So, what do you mean by analog signal? Analog means continuous time signal. Continuous, suppose it is a sinusoidal signal, it is we can say it is a continuous signal or analog signal. If x axis is your time axis and y axis, this is your y axis you can represent it by, you may take as voltage or current, suppose it is your voltage, this is a sinusoidal signal and we can say it is an analog signal or a continuous signal. What do you mean by digital signal? So, digital signal is nothing but discrete type of signal. Discrete type of signal, that means in case of digital electronics, so that may be the digital signal, that is your 1 and 0 binary languages or machine languages 1 or 0. In a digital signal, physically you will found there are two level, one is your 0 level, we can 0 volt, low level, we can say mark it as 0 or it may be 0 volt, and high level that is your plus 5 volt. In plus 5 volt we can represent as a binary 1. So, low level, that is your 0 volt, can be represented as your binary 0 and high level or plus 5 volt can be represented as your binary 1. So, in digital signal, digital electronics, it is the branch of engineering which deals with the digital signals or digital, that is your binary 0 and 1, there is your machine languages or binary languages which computer can understand. This is your, as far as the digital signal is concerned. In analog signal, there is a continuous time of signal. In continuous time signal, the signal is continuous, there is no discrete. In continuous time signal, it may be sinusoidal signal, if x axis is your time, y axis may be voltage or current, like this. This is the basic concept of what is the difference between the analog and digital one. So, now today we will cover up analog. Introduction to analog electronics. In analog electronics, we will cover up first is your basic, that is your what is load line, operating point, or we may say Q point, operating point or we may say Q point, biasing, stabilization, then stability factor, so as far as transistor as an amplifier, first of all we will go through these points, what is load line, what is operating point, what is biasing, what is stabilization, what is stability factor, all of these. So, now first of all you will understand a basic common emitter transistor. In a common emitter transistor, why the name is so called the common emitter transistor? In a transistor configuration, basic transistor configuration, there are three configurations, one is your common base, another one is your common emitter and third one is your common collector configuration. So, in most of the configuration generally we are taking common emitter configuration. Why we are using common emitter configuration rather than common base and common collector? In common base there are three configurations, common base CB, common emitter CE and common collector CC configuration. In most of the cases transistor as an amplifier, in case of transistor as an amplifier, So, we are maximum time we are using common emitter configuration rather than common base and common collector. Why? In common emitter configuration there are 4 parameters we can judge whether the transistor as for good amplification or faithful amplification the criteria must be satisfied. There are 4 parameters. As far as parameter is concerned, one is your voltage gain, input impedance, output impedance, so voltage gain is nothing but output by input. Voltage gain means output voltage by input voltage. Input impedance is nothing but resistance input voltage by input current as far as input impedance is concerned. Output impedance similarly output voltage by output current. In case of common emitter configuration there is a standardized voltage gain and standardized input impedance and output impedance. But in case of common emitter base configuration which input impedance is low and output impedance is maximum infinity. But in case of common collector configuration similarly input impedance is infinity, output impedance is low. Input impedance is low, output impedance is maximum. So, to avoid this, so we must use common emitter configuration rather than common base and common collector configuration. Transistor. First of all, we must know the basic. The term is transistor. What do you mean by transistor? Transfer the low resistance path through high resistance path. Transfers low resistance path through high resistance path. So, that means suppose this is your transistor, we are providing input and you will get the output. This is your input and this is your output and this is your transistor. Suppose we are giving the input voltage, let input voltage is your Vi and output voltage we are getting, that is your output voltage, that is your V0. So, there is a gain means output by input. If you will say voltage gain, that is your output voltage by input voltage. So, output voltage by input voltage is nothing but is your gain. So, gain in case of equal to output voltage V0 by input voltage Vi. So, we are providing the input to the transistor, input is your small millivolt or microvolt. Suppose a signal we are giving the input, here a sinusoidal signal, suppose I may say here amplitude is your suppose 10 millivolt. So, this amplitude determines whether the signal is low or high. This is your 10 millivolt signal we are applying. Your y axis is your voltage and x axis is your time axis. The output we are getting some volt. Say this is your 1 volt, here plus 1 and this is your minus 1 volt. This similarly this is your 10 millivolt and this is your minus 10 millivolt. So, transistor we are giving the input is your 10 millivolt signal, in output we will get say 1 volt signal. What is gain? Output by input. So, this is a ratio, no units. So, output by input. Output is your 1 volt. So, that is your output equal to 1 volt divided by 10 millivolt. Milli is your 10 to the power minus 3. So, your denominator that is your 10 millivolt, that is your 10 into 10 to the power minus 3. So, 10 to the power minus 3 come to the numerator, that is your 10 to the power plus 3. So, there will be gain in 1 10 millivolt input signal and output you are getting 1 volt signal. So, gain will be how much? That is your 10 into 10 into 10 to the power that is your here 10 millivolt, that is your 10 to the power plus 3 divided by 10, that will be 100. So, gain is your 100. So, if input is your 10 millivolt signal, output is 1 volt signal, that means the output is 100 times the input signal. We can say this is the transistor as an amplifier, that means output is amplified. How to get the amplified signal? That means the input 10 millivolt signal can be converted into your 1 volt signal, that is your, this is your amplified signal. So, how to get the amplified signal, that is important. If you will get the amplified output, there are certain criteria. So, you must know what is load line, what is operating point, what is biasing, what is stabilization and what is stability factor. First, now I am going to draw a simply common emitter transistor. So, now I am drawing a simply common emitter transistor. Common emitter transistor. So, just now I am tell you some brief introduction of the simply transistor. So, transistor, it may be your NPN transistor or it may be PNP transistor. It may be NPN or it may be PNP. Suppose this is your NPN transistor. In a transistor, this is a 3 terminal. 3 terminal is your one terminal is your emitter terminal. It can be denoted as E. Another terminal is your base terminal, that is your B, and another terminal, that is your collector terminal, that is your C. So, it is a 3 terminal, 2 junction. This is your junction. We can say that this is your emitter and this is your base and this is your collector. The one layer, this is your emitter base layer. We can say that this layer, we can say that emitter base layer, emitter layer, and this is your base and this is your collector. And this junction, we can say that this is your emitter base junction. We can say that this is your input junction or emitter base junction. And this is your another junction, we can say that this is your collector base junction. So, it is a 3 terminal, 3 layer, 2 junction electronic device. 3 layer, 3 terminal, 2 junction electronic device. So, this is your NPN transistor. Why the name is called the NPN transistor? So, you already know that the N type semiconductor and P type semiconductor. What is N type semiconductor? That is a pure semiconductor. When a pure semiconductor is doped, means if you are adding some impurity, it becomes impure. What is the necessity to add that impurity to the semiconductor? Pure semiconductor, to increase the conductivity. So, there are in a semiconductor there are 2 types of semiconductor. One is your in pure form, another is your, if you add some impurity, it becomes impure, that is called the N type semiconductor and P type semiconductor. So, in semiconductor there is your N type semiconductor. How will get the N type semiconductor? In N type semiconductor, when a pure semiconductor adding some pentavalent impurities means there are 5 electrons in the outermost shell. If you add some pentavalent impurity, it becomes impure and the resulting semiconductor is called the N type semiconductor. In case of P type semiconductor, when a pure semiconducting material, if you add some P type means trivalent impurities like gallium, indium, aluminum, then the resulting semiconductor is called the P type semiconductor. So, in N type semiconductor, the majority charge carrier is electrons. So, in semiconducting material, so there is your silicon and germanium. This is your silicon. In silicon, in semiconductor material, there are 4 electrons in the outermost shell. There are 4 electrons in their outermost shell. So, if you add some pentavalent impurities, then that means what? Pentavalent means there are 5 electrons in their outermost shell. There are 5 electrons in their outermost shell. So, that means, so this is your a pentavalent impurities. When a pentavalent impurities this is your say pentavalent impurity atom. Pentavalent impurity atom say like your silicon semiconductor material like your germanium and silicon. When this is your pentavalent impurity atom. pentavalent impurity atom. This is your silicon, this is your silicon, this is your silicon, this is your silicon, 5. So, it covalent bonded with this is your silicon, silicon, silicon and silicon. In a pentavalent impurity atom, there are 5 electrons in the outermost shell and there are 4 covalent bonds and another there is a 1 electron will be excess. These are donors. So, every pentavalent impurity atom, each pentavalent impurity atom donate 1 electrons. If you add million and million number of pentavalent impurity atom to a semiconductor, million and million number of extra electron will be produced which take part in the current conduction. So, this is your N type and this is your P type semiconductor. In N type and P type, there are two N and P. These two N type semiconductor are fused with a P type semiconductor which formed NPN transistor. Similarly, in case of PNP transistor, this is your P, this is your N and this is your P. Similarly, this is your emitter and this is your base and this is your collector. What is the basic difference between NPN and PNP transistor? In NPN and this is your PNP, in PNP there are two P type semiconductor are fused with N type semiconductor and same thing, this is your 3 layer, 3 terminal and 2 junction electronics device. And this is in case of NPN transistor, the symbol is like this. The symbol is like this. This is your emitter and this is your base and this is your collector. This is in case of PNP transistor, the symbol is like this. This is your emitter, this is your base and this is your collector. We can say that this is your N, this is your N, this is your P and this is your N. In case of PNP, this is similarly this is your P and this is your N and this is your P. What do you observe? The basic difference between NPN and PNP. This arrow mark indicates the direction of current, emitter current. This is your direction of the emitter current and this is your arrow mark outward and this arrow mark inward. This is your emitter towards the base, this is the current flow away from the emitter. This arrow mark indicates this is your NPN transistor and this is arrow mark inwards to the base, that means current flow emitter currents towards the base which indicate this is your PNP transistor. NPN and this is your PNP transistor. This is your symbolical difference between NPN and PNP transistors. So, then now I am drawing a simply common emitter transistor, how the transistor amplified the input signal. In a common emitter transistor, this is your N, this is your P and this is your N. So, already I told you that there are two junction and 3 layer electronics device. This is your input junction. Input junction must be forward biased in basic electronics. So, there is a forward biasing, reverse biasing, all things you have already studied. In what do you mean by forward biasing? Forward biasing means one is forward biasing, another one is your reverse biasing. What do you mean by forward bias? Bias means what? If you add some voltage to the circuit, we can say that bias. In forward bias, the P terminal should connected to the positive and N terminal should be connected to the negative. This is the basic connection of how to connected a electronic circuit. If you are using NPN or PNP transistor, if it is a forward bias, the P terminal must be connected to the positive supply of the battery and N terminal should be connected to the negative supply of the battery. This is your forward bias case. In case of reverse bias, so P reverse, that is your P terminal should be connected to the negative terminal of the battery and N terminal should be connected to the positive terminal of the battery. This is your forward biasing and this is your reverse biasing. Why the transistor input is forward biased, why the output is reverse biased? In forward biasing means if the junction is forward biased, the width of the depletion layer will be reduced. When the width of the depletion layer will be reduced in PN junction, the current conduction is possible. So, this is in case of forward biasing, but in case of reverse biasing, Reverse biasing means the width of the depletion layer will be increased. If the width of the depletion layer increased, the limitation of the current. To avoid to view of this, so we must, the input junction must be forward biased and the output junction must be reverse biased. In case of common emitter transistor, this is your NPN, here this is your emitter terminal, this is your base terminal and this is your collector terminal. So already I told you, so this arrow mark terminal must be your emitter terminal and must be emitter terminal, this is your base and collector. You can easily identify which terminal is your base, which terminal is your emitter, which terminal is collector. This is a plate, that means this is your base. Then either of these terminal, how to identify which terminal is emitter terminal and which terminal is your collector terminal. This arrow mark terminal must be your emitter terminal and another terminal is your collector terminal. So next is your how to connect or connect the resistor and voltage resistance and voltage source. So this is your base and emitter. In base and emitter, this is your input. In emitter base and this is your output is your collector base. So here since the emitter, base and collector, emitter is common between base and collector, the name is called the common emitter configuration. In common emitter configuration, so I am giving here the input signal, the signal must be amplified and then there is a voltage source. Already I told you the input junction must be forward biased. Forward biased means P terminal should connect to the positive and N terminal should connect to the negative. This is your P terminal. P terminal should connect to the positive terminal of the battery and here N is connected to the negative terminal of the battery. This is your battery source, this is your DC source, battery source. Similarly here there is a resistance, means load resistance, suppose there is your RC, collector resistance, and here we are providing another source. Already I told you the input junction must be forward biased. Forward biased means if there is N must be forward biased means N must be negative and P must be positive. So here output is reverse biased. Tell me, this is your N terminal. This must be what? Reverse biasing means N is negative. If it is reverse bias, N must be positive and this will be negative. Are you clear or not? This is forward bias by application of this or providing this source, and this source giving this junction will be reverse bias. So this is your battery B and this is your E. We can say that this is your VBB and this is your C, collector terminal, this is your collector supply voltage, that is your VCC. So simply this is a simple common emitter transistor circuit. And another thing is, and the current flow is current flowing from positive to negative like this is your current, and similarly the current is flowing like this. You must know which branch and the current direction, the current flowing through which branch and the current either entering this branch or leaving this branch. So this is your base terminal. Look at this is your positive terminal and this is your negative terminal. Current is flowing is a clockwise. That means the direction of the current is like this. Since this is your base, we may say what? Which current? Obviously this is your base current. This is your base current, that is your I suffix B. This IB represents the base current. That means this connection, this is your base, we can say that this is your base current. Similarly, you can say that this is your collector terminal, the current must be what? This is your IC, collector current. Similarly, this is your emitter, the current is what? IC. Are you clear or not? This is your base current, this is your collector current and this is your emitter current. This is your signal. So you might have asked the questions, there is a battery, there is a signal, what is the necessity of this battery? So already I told you, the input junction is forward biased and output junction is reverse biased. So there is one term is your zero signal collector current. In your transistor and amplifier means when we are applying the small millivolt or microvolt signal and we will get a amplified output some volt. So if the input junction is forward biased during positive half cycle of the input signal, look at this here, this is your positive and this is your negative, positive half cycle and this is your negative half cycle. So during positive half cycle of the input signal, that means what? This junction is forward biased and you will get the current at the output, this is your output. This is during positive half cycle of the input signal, this is your input signal, let V in, and this is your time axis. During positive half cycle of the input signal, during positive half cycle of the input signal, the input junction is forward biased, likewise base current, collector current, emitter current you will found, then that means what? You will get the output. During negative half cycle of the input signal, during negative half cycle of the input signal, what? The junction will not forward biased. Already I told you, the input junction, if it is forward biased, P terminal should connect to the positive and N terminal should connect to the negative. If during the negative half cycle of input signal, the junction is reverse biased, that means no current will flow through the output. So, that means to keep the input junction forward biased, say additional battery source is provided. Are you getting or not? Why I am giving this is your battery source. So, during positive half cycle of the input signal, input junction is forward biased and you will get the output. During negative half cycle of the input signal, the input junction is not forward biased. That means you will not get the current at the output. To keep the input junction forward biased, this battery source is provided. During the battery, the current flow at the output, that is called the zero signal collector current. That is called the zero signal collector current. It is very, very important. That is your zero signal collector current. Zero signal collector current. Zero signal collector current, that is your IC. Are you getting or not? So, that means transistor as an amplifier, if you are not providing a proper DC source, that means you will not get a zero signal collector current. That means transistor will not amplify the input signal properly. So, that's why, so first in analog electronic circuit, in a transistor biasing, you must know what is the zero signal collector current. In zero signal collector current means absence of the input during the negative half cycle of the input signal, the input junction is not forward biased. To keep the input junction forward biased, a battery source provided. Due to this battery source, the current is nothing but at the collector terminal, that is called the zero signal collector current. So, in a transistor there are three current, one is your base current, another one is your emitter current, another one is your collector current. So, here emitter is nothing but, this is your emitter current IE, this is your base current IB, this is your collector current, that is your IC. So, your total charge carrier emitted by the emitter, and the current is your emitter current. So, emitter current IE equal to base current plus collector current. So, emitter current equal to base current plus collector current. So, emitter, if the emitter 1000 electrons emitted by the emitter, the base is very lightly doped, few 5% of the holes are combined with the electrons constitute a current, or that is your base current, and the remaining 95% of electrons collected by the collector. So, that is why the emitter current equal to base current plus collector current. Then this is nothing but zero signal collector current. So, in a transistor biasing, first of all, what do you mean by the zero signal collector current? In the absence of the signal, the current flow at the output, that is your zero signal collector current. Next one is your Q point. Q point or operating point. What do you mean by Q point? The point where the transistor is operating. The point where the transistor is operating, that is called the Q point. Okay. The zero signal values of IC and VC, the zero signal values of IC and VCE, VC means collector emitted voltage, is nothing but Q point, or the point where the transistor is operating is called the Q point, or the point where the transistor is silent is called the Q point. The point where the transistor, the stabilization, very good stabilization is called the Q point.